In this lesson, we are going to finish our study of random variables. So the first thing we'll do is just a quick review of those binomial random variables again. Remember that the mean of a binomial random variable is NP, and the standard deviation is the square root of NP times 1 minus P. Suppose you have a binomial distribution with n equals 300 trials and P equals 0.3. For instance, this might be the distribution for x is equal to the number with a particular gene in a sample of 300 persons randomly selected from a population in which 30% has the trait. Given this information, find approximations of mu and sigma. So mu is equal to NP. So if 30% of the people in the population have this trait, we would expect on average 30% of our sample to have it. So 300 times 0.3 gives us 90, which is 30% of the sample. And sigma tells us how much variability we're going to see in our samples of 300. That's root NP times 1 minus P, which is root 300 times 0.3 times 0.7. And comes out to be approximately 7.937. So a random sample of 1,000 eligible voters is drawn, and we're going to let x equal the number who actually voted in the last election. And it is known that 60% of all eligible voters did vote. Using statistical software, Excel, or a graphing calculator, find the exact Miller probability that 620 or fewer individuals in the sample voted. So we want the probability that x is less than or equal to 620. If you had to do this by hand, you'd have to do probability that x is equal to 0, plus probability that x is equal to 1, oh my gosh, all the way up to the probability that x is equal to 620. That would be super big pain in the butt. But here's the Excel command. Type in binom dist. First comes your k, which is 620. Next comes your n, which is 1,000. Then comes your probability of success. Well, that's our 60%, so 0.6. And then, is it a CDF? Do we have a less than or equal to? Yes. So you say true. So remember, this is the K, N, P. Is it a CDF? Yes, true, no, false. And that should come out to be 0.907. So use that answer and go try to type that stuff into Excel yourself, and then come back and watch the rest of the lesson. A pharmaceutical company claims that only 20% of those taking its new allergy medication will experience drowsiness. To test its claim, it randomly assigns 500 people to take the new medication and measures x equal the number who experience drowsiness. So compute the mean and standard deviation of x. So the mean is NP. So n is 500. Probability of success or drowsiness is 0.2. So that gives us 100. So in a sample of 500, we kind of expect to see about 100 people experiencing drowsiness. Okay, our standard deviation sigma tells us how much this is going to vary. NP 1 minus P. So 500 times 0.2 times 1 minus 0.2, which is 0.8. This comes out to be approximately 8.944. Okay. Use statistical software to find the exact final probability that the number who experience drowsiness will be 110 or more. So what's the chances that their sample is going to have 110 people or more being drowsy? So Is probability x is bigger than or equal to 110. Well, we have to use complementing here. And with binomials, you have to be careful about equal to's here. So being bigger than or equal to 110, so that's from 110 on up, is the opposite of 109 on down. This is a discrete random variable, and the or equal to's do really matter here. Okay, using Excel, we're going to find the probability that x is less than or equal to 109. So that's binom dist. Our n is 109. Or sorry, k is 109. Our n is still 500. Probability of success is 0.2. And true, we want the CDF. And that comes out to be 0.856 approximately. So, probability x is bigger than or equal to 110 is 1 minus this number, or 0.144. There's a not super high chance that they're going to see more than 110 people experiencing drowsiness. So the last lesson in this chapter talks about sums, differences, and combinations of random variables. So here is how we find the mean, variance, and standard deviation of a linear combination of variables. So if we take two variables and add them together, then the mean of x plus y is the same as the mean of x plus the mean of y. You could think like if x was husband's height and y was wife's height, if we want to find the average of the husband's and wife's heights, husband plus wife, and see who makes the taller couple, you could average the husbands, average the wives, and then add them together. And the same thing for the difference, subtract the means. And a variance is also an operator that works this way. The variance of x plus y is variance x plus variance y, and the variance of x minus y is variance x plus variance y. The kind of interesting thing here is that this minus doesn't matter. That reason's a little bit more technical than we're going to go into in this course, but it doesn't. And then, to find the standard deviation, you take the square root of the variance. So one pretty special case is linear combinations of normal random variables, because these also end up being normal, which is a bit special. So if you have x and y, which are two independent, normally distributed random variables, a and b, which are some numbers, either positive or negative, then the random variable L, which is equal to ax plus by, is normally distributed, and in particular, x plus y has mean mu x plus mu y, so the new mean is you add the mean for the first plus the mean for the second, and standard deviation is the first standard deviation squared plus the second standard deviation squared, all rooted. And the same thing for subtraction, except for the mean is just the difference of those two means. And let's just talk about how this first one relates to the thing we had in the box above. So we had variance of x plus y is equal to variance of x plus variance of y. That's from the box we have above. Now, the standard deviation of x is sigma sub x. So the variance of x is sigma sub x squared, because that's how you go backwards from standard deviation back to variance. And similarly, the variance of y is going to be sigma sub y squared. So there we have the variance of x plus y is sigma sub x squared plus sigma sub y squared. So to find the standard deviation, we'll call it STDev, x plus y, you take the root of this expression, and that's where that formula comes from. All right, here's an example. Suppose the length of time a person takes to use an ATM machine is normally distributed, and it has mean of mu equals 100 seconds and a standard deviation of 10 seconds. There are 4 people ahead of Jackson in a line of people waiting to use the machine. He's concerned about the variable t, which is the total time for the 4 people will take to use the machine ahead of him. So the first thing is, what is the mean? So we'll call this mu sub t. Well, that's going to equal the mean for his first wait plus the mean for his second person, mean for the third person plus mean for the fourth. And those are all 100. Which comes out to be 400 seconds. Okay, assuming that the times for the 4 people are independent of each other, find the standard deviation of t. So we were told that the standard deviation of t, let's call it s sub t. No, sorry, not s, we'll call it sigma sub t because we're talking about the true value. So sigma sub t is going to equal the square root of the first standard deviation squared plus second standard deviation squared plus third one squared plus fourth one squared. And so that's like of the first weight, second weight, third weight, fourth weight, but each weight is the same, really. It's just this thing being repeated. So you have 10 squared plus 10 squared plus 10 squared plus 10 squared is root of 400, which happens to be 20. So that's our standard deviation. One thing to note, this is not 10 plus 10 plus 10 plus 10. So as in, it's not adding up the 3 different standard deviations. That's wrong. So the rule we have is about variances, and what you're trying to do when you say this thing that's wrong, you're trying to say that that square root distributes over addition, which it does not. So be very careful about that. Jackson hopes the total time t is less than or equal to 360 seconds, which is 6 minutes. Let's find the probability that he's waiting less than 6 minutes to use this ATM machine. So probability that t is less than or equal to 360. Well, we need to standardize that variable, and our new mean, mu sub t, was equal to 400. Our standard deviation, sigma sub t, was equal to 20. So our z-score is x, which is 360, minus our mean, which is 400 over 20. And that gives you a z-value of -2. So the probability that his wait time is less than 360 seconds is the same as the probability that the z-score is less than or equal to -2. And if you look at the table, the z-table you have, this is 0.0228. So it's 2.28% chance he's waiting less than 360 seconds, which means he's probably waiting longer. Combining binomial random variables is another sort of large class of variable you've been working with, or large family of variables. So a linear combination of binomial random variables is generally speaking not a binomial random variable. And the reason is that a binomial random variable has a certain success probability, and if those 2 success probabilities are different, you can't have one big overarching success probability. On that vein, the only exception to this is when the probability of success is the same in your 2 trials. Then you can combine things and analyze them as a single experiment, but only if you have the same success probability. Otherwise, the variable that you get will not be binomial. So Isabelle and Taylor worked together on a group quiz that has 15 multiple choice questions, each with 4 choices for the possible answer. Unfortunately, neither had the time to study, so they decided to randomly guess at answers. Isabelle guesses answers for the first 7, and Taylor guessed the other 8 questions. So first of all, for any single question on the quiz, what's the chance of a correct guess? Well, there are 4 choices for each question. So assuming that each is equally likely, the probability of success is 0.25, just by randomly guessing alone. Okay, let x equal the number of correct guesses that Isabelle makes. What are the values of n and p for this binomial distribution that describes x? So for Isabelle, she guessed on 7 questions, so her n is 7. Success probability is 0.25. And we're going to have y be the number of correct guesses that Taylor makes, the values of n and p for this distribution. So she guessed on 8, so n is 8, p is equal to 0.25. So consider the linear combination x plus y, which is the total correct guesses that they make. What are the values of n and p for this binomial distribution? And how do you know that this is going to be binomial? So n, well, this is the total number of events in x and events in y. So, or number of trials, that is. So n is 15. And probability of success is 0.25. And how do you know this distribution is going to be normal? And it's because the success probabilities of x and y are both 0.25, or they're both the same. So in this case, we will get another binomial random variable. So give the mean, variance, and standard deviation of the sum x plus y in each of the following cases. You can assume x and y are independent. For any situations covered in section 8.8, name what distribution the sum has. That's kind of an if any. Okay, so x is a binomial random variable with n equals 10, p equals 0.5, and y is a binomial random variable with n equals 20 and p equals 0.4. So just at the top you can note that x plus y is not binomial. And the reason is that there's different success probabilities. Okay, but we can still find the mean and variance and standard deviation in that order. So first the mean of x plus y. We're told that's the mean of x plus the mean of y. Well, these things are both binomial. So the first one's mean is NP, so 10 times 0.5. The second one's mean is also NP, just with a different n and different p, 20 times 0.4, which comes out to be 13. 5 plus 8, 13. So there's your mean. We'll call that mu x plus y as a subscript. I'll fix that because it looks so sloppy. Okay, next the variance. I'm just going to abbreviate that var because that's just so much to write. Var x plus y is variance of x plus variance of y. Okay, so for a binomial random variable, we know that sigma is root np1 minus p. That's the standard deviation. So the variance, sigma squared, is np1 minus p. So that's 10 times 0.5 times 0.5 plus 20 times 0.4 times 0.6. That comes out to be 7.3. So that's sigma sub x plus y squared. The squared things mean you have the variance. And then the last thing, the standard deviation, is just the square root of the variance. So sigma sub x plus y is root 7.3, which comes out to be about 2.7. Now if x is a normal random variable with mean mu and sigma equal 15, and y is this also the same random variable, also mean mu, sigma equals 15, well then x plus y will be normal. We're going to find its mean and standard deviation. So mean x plus y is mean of x plus mean of y. Alright, x's mean is 100, y's mean is also 100 for a new mean of 200. The variance of x plus y is variance x plus variance y. Remember, variance is sigma squared. So sigma x squared plus sigma y squared. And those are both 15. So you have 15 squared plus 15 squared. Well, both of those are 225. When added together, they add up to 450. And then the standard deviation is the square root of the variance, or approximately 21.213. And suppose you've got some weird thing where you have a normal random variable and then a binomial random variable, and so you put them together. Weirdness ensues. Okay, so this is not a standard distribution. So x plus y, something non-standard, at least for this class. But we can still find the mean and the variance and the standard deviation. So the mean of x plus y is the mean of x plus the mean of y. Now the mean of x, that's the first one, which is just mu, 100. Y is binomial, so its mean is NP, or 200 times 0.25, giving us a mean of 150. Then let's find the variance. So the variance of x plus y is the variance of x plus the variance of y. This kind of combines the previous two formulas. We have sigma sub x squared, and the binomial variance was np1 minus p, much like in part A. So this is 15 squared plus 200 times 0.25 times 1 minus 0.25, or 0.75, which comes out to be 262.5. And then the standard deviation, which I'll just call STDev, is the root of that stuff, which is approximately 16.2. And one more example. So Annamarie is trying to decide whether to take the train or the bus into the city. The train takes longer, but it's more predictable than the bus because there are no traffic delays. Train times are approximately normally distributed, with mean at 60 minutes and standard deviation 2, while bus times are also about approximately normally distributed, with mean 50 minutes and standard deviation of 8. The bus and train times are independent of each other. Find the probability the train is faster on any given day. So let's start by defining some variables. Let's let x equal the train time, and we'll let y equal the bus time. If the train is faster, that means that x is less than y, which is the same thing as saying x minus y is less than 0. So what we're going to do is we're going to look at the probability that x minus y is less than 0. And to do that, we're going to need to do a z calculation, and for that we're going to need to find our standard deviation and our mean. Okay, so first of all, the mean. Mu x minus y. Well, that's the first mean, which I'm going to call mu x, minus the second mean, mu sub y. So train 60, bus 50, new mean you use is 10. Okay, we need to find the variance first because that gets us the standard deviation. So I'll call it sigma sub x minus y squared. That's sigma x squared plus sigma y squared. So the first standard deviation was 2. So 2 squared plus 8 squared gives us 4 plus 16 is 20. So therefore, just plain old sigma is root 20, which is approximately 8.246. Okay, and you're pretty much ready to go now. So the probability that x minus y is less than 0 equals probability that some z is less than something. So find your z-score. So this time your x value is 0. Your mean is 10. Your standard deviation is 8.246, which comes out to be negative 1.21. So that's your x value mean over sigma, except for your x value actually is this x minus y value. Now from your table, you see that this is 0.1131. So even though the bus is less predictable, the probability that the train is faster is actually quite low, only about 11% of the time. So it's better to take the bus, even though it might be frustrating to sit in traffic jams.